equivalent circuit of the transformer that we have discussed, right? So that is how we will develop the equivalent circuit of the transformer. Similarly, if I want to develop the equivalent circuit either with respect to primary side or either with respect to secondary side, how to shift one circuit parameter to other circuit also, that we have discussed, right? That is if I wanted to represent the equivalent circuit with respect to primary, then what modifications I need to do in the secondary circuit elements. And similarly, if I wanted to represent the equivalent circuit to the secondary side, the primary circuit elements, if I wanted to shift to the secondary, how the circuit elements that will be get changes, that we have discussed, right? So let me recall once again that. So if I in this case, this case which referred to the primary side, we will have this is the circuit diagram which is referred to the secondary side, right? So in order to represent the equivalent circuit with respect to the primary side, what we have done, whatever the primary circuit elements that we have, I'm keeping the same, and the secondary circuit elements I'm shifting onto the primary side, so that the secondary circuit elements completely it was on the primary side we will have, and the total elements on the primary circuit we will get. So the equivalent circuit either that is without representing in the secondary side, all the elements are represented in the primary side, so that we will get the complete equivalent circuit with respect to the primary side. But during this transformation of secondary elements to the primary circuit, definitely resistance and reactance will be get changes. Now see here in this circuit, this is the circuit representation both with respect to primary and as well as the secondary. So here whatever the secondary resistance and secondary reactance whichever we have on the secondary circuit, if I shift to the primary circuit, then these values of resistance and reactance will be get changes, right? So that new value, when you shift the secondary resistance and reactance to the primary circuit, what the value that will be get changes. So this resistance, if you shift to the primary side, then the new value of resistance it is going to be that resistance we are representing with R2 dash. This R2 dash which represents the secondary resistance with respect to primary. Secondary resistance with respect to primary. Okay, so that new value of resistance, how can we calculate? Already the formula to calculate that also which will be given R2 dash, which is equal to the value of secondary resistance divided by square of the transformation ratio K. That is R2 dash is equal to, therefore we will get R2 divided by K square. So this R2 divided by K square, if you done then R2 dash, it is the value of secondary resistance with respect to primary. So simply what conclusion that we can make from this is, in case if you shift the secondary elements to the primary side, then simply the secondary element value, it is to be divided with the square of the transformation ratio. Similarly, not only for the resistance, also for the reactance and as well as the impedance also the same we will get. So the value of secondary reactance, if you should shift to the primary side, then the secondary reactance it is to be divided with the square of the transformation ratio. Similarly for impedance also, Z2 dash, the new value of impedance with respect to primary, which is equal to secondary impedance divided by square of the transformation ratio we will get. So this is how we can shift or we can transform the secondary elements to the primary side. In a similar manner, the value of primary circuit elements we can shift from to the secondary circuit, which is shown in the that is the loss diagram. This is referred to secondary. So here secondary circuit elements I have keep the same, but I have changed the primary circuit elements to the secondary side. So if I shift the primary resistance R1 to the secondary side, the new value of resistance which is going to be R1 dash, and reactance if I shift to the secondary side, then the new value of reactance which is going to be X1 dash, and similarly Z1 which is after shifting it is Z1 dash. So the new value of resistance with respect to secondary, how can I calculate? Simply by multiplying the square of the transformation ratio. R1 dash is nothing but the primary resistance with respect to secondary. That new value of resistance I can calculate by multiplying the existing resistance with the square of the transformation ratio. This is how we can change one circuit element to the other circuit, and thereby we can represent the equivalent circuit of the given transformer. So in the three ways we can represent the equivalent circuit. That is both with respect to primary and secondary. And if you want to denote with respect to primary alone, we can shift the secondary elements to the primary side, and only the equivalent circuit you will get with respect to primary then. And similarly, primary circuit elements, all elements you can shift to the secondary side. So complete equivalent circuit you can also represent with respect to the secondary side. So these are the three possible ways of representing the equivalent transformer. And finally, we concluded with the equivalent resistance with respect to primary and as well as the secondary. That value of total resistance with respect to primary R01, which is given by R1 plus R2 dash. Here R2 dash is equal to what? R2 divided by K square. R2 dash is equal to R2 divided by K square. Similarly, X01 is equal to X1 plus X2 dash. Z01 is equal to Z1 plus Z2 dash. Similarly, R02 is equal to R2 plus R1 dash. X02 is equal to X2 plus X1 dash, and Z02 is equal to Z2 plus Z1 dash. Okay. So till now, till this topic which we have discussed in the last class. Now let me tell you what is meant by the voltage regulation and what is meant by the efficiency, and how these voltage regulation and as well as efficiency which plays an important role in the operation of the transformer. Nextly, what are the tests that we will conduct to find out this voltage regulation and as well as the efficiency we will discuss, and later how to draw the characteristics based on the testing that we have done on the transformer we will discuss them. Okay. So firstly, let me tell you what is voltage regulation. Voltage regulation means when a transformer is loaded with constant primary voltage, the secondary voltage decreases because of its internal resistance and leakage reactance. This is already we know, right? Suppose this is suppose let us take a transformer. Now see here, this is a transformer representation, right? Let us consider there is no load onto the transformer. Then what will happen? There will be no current flowing through the secondary winding as well as the load. So I2 current which will becomes 0. If there is no load current I2, that is I2 is equal to 0 if it is, then what will be the voltage drop across this resistance? I2 R02 is equal to, sorry, I2 R2 is equal to 0. Similarly, what will be the voltage drop due to this reactance also going to be I2 X2. Since I2 is equal to 0, voltage drop across this reactance also going to be equals to 0. So during the no load condition, there is no load placed onto the secondary winding. There will be no load current which will be flow through the load, and simultaneously the corresponding voltage drop across the resistance and as well as the reactance which will becomes what? 0 only. So that is what which I am explaining here. See, if you study this, we come to know when transformer is loaded with a constant primary voltage, then the secondary voltage which will be decreases of its internal resistance and as well as the leakage reactance. So if there is no load, then there is no voltage drop. So when we place some load onto the secondary winding, definitely load current starts to flow, and this load current I2 which is flowing through the load causes some amount of voltage drop in the secondary winding resistance and as well as the secondary winding inductance, that is due to the inductive reactance, isn't it? So these voltage drops which will definitely decreases the amount of secondary voltage when we are supplying with the constant terminal voltage and when it is loaded, right? So this voltage, this E2 is nothing but let us consider secondary terminal voltage at the no load. Already we know E2 is nothing but amount of voltage which inducing in the secondary winding. So if there is no load onto the transformer, then what will happen? There will be no voltage drop in the respective secondary winding resistance as well as secondary winding inductance, and therefore whatever the induced voltage G2 which will be there, that will be entire voltage that will be present across the load. So E2 which is going to be equals to secondary terminal voltage during the no load condition. Okay, and V2 is nothing but the terminal voltage. So when there is a load placing onto the transformer, definitely the amount of induced voltage and the secondary terminal voltage slightly it will be get differs in value. Why it is so? Because there will be some voltage drop due to the resistance and as well as the inductance. So from this induced voltage, if you deduct the value of voltage in the resistance and as well as the reactance, then the resultant voltage which is nothing but the value of secondary voltage across the load we will get. That is the secondary terminal voltage on full load condition we will get, right? So the change in secondary terminal voltage from no load to full load is nothing but how much it is going to be equals to. It is not V2 not anta karithvi. This V2 not which represents the value of voltage during the no load. This V2 is nothing but value of voltage during the load. So from no load to full load, if you deduct, then it is the value of change in secondary terminal voltage from no load to the full load we will get. So definitely during the no load, there will be higher value of voltage while compared with the on load condition. So this difference to the no load voltage which gives the percentage voltage regulation. This change which is divided with V2 naught is known as regulation down. Okay. If this change is divided with V2, that is a full load secondary terminal voltage, then it is called as regulation up. Regulation is of two types we can calculate: regulation down and as well as regulation up. Regulation down means the denominator part which is going to be no load voltage, and when you are calculating the regulation up, then we need to take the denominator term as the full load voltage. But in the numericals, if it is not specified whether it is a regulation down or regulation up, default we should consider it as a regulation down only. In general, we will represent the regulation with respect to the no load voltage only. Okay. In case if he specifies clearly it is a regulation up, then we should consider it as the secondary full load voltage, that is V2. Unless he specifies a regulation up, if it is not specified, then I simply said that it is a regulation means if the default we should consider it as regulation down only. Okay. So percentage voltage regulation we can just represent it with VR cos phi plus or minus Vx sin pi. Now let us discuss how this percentage voltage regulation, which is going to be VR cos pi plus or minus Vx sin pi, we will get with the making use of the vector diagram. I will derive this condition. Okay. So here plus which represents for lagging power factor as we already know, and minus the sign which is represented to use for the leading power factors. Okay. The significance. What is the significance of the voltage regulation? So the value of voltage regulation always we wanted to be less for the better operation of the transformer. As much as less it is means that much good operation the transformer it is having, like that we can tell it is. So the regulation always we wanted to be as minimum as possible. So regulation minimum to be get what should be the condition? The numerator part should be the minimum in value, that is V2 naught minus V2, it should be lesser in value. If you have then regulation value which is always going to be lesser in value we will get. So in order to get this value numerator term to be less, there should be very less amount of voltage change from no load to full load. If we have, then lesser the voltage regulation we will get. Or simply we can say when the regulation which will be equals to 0, when there is no change in level of voltage from no load to full load, then we can say the regulation value which is going to be 0. But for the practical transformer, it is not possible to get the 0 regulation. Only for the ideal transformer it will be possible to get that. For the practical transformer, usually regulation which is going to be varies from 0 to 5%. It depends upon the device to device. Okay. But as minimum as possible if you have, then we can say the performance of that particular device is as good as. Okay. So always the regulation is to be as minimum as possible only. Okay. This is what the value of voltage regulation is less, the better the transformer and the transformer efficiency, because a good transformer should keep its terminal voltage as constant possible for all load conditions of the load. Okay. So the regulation may be explained in terms of primary values also. Here I have represented with respect to primary. So the secondary no load terminal voltage as referred to primary, we can define it as E2 dash, which is equal to E2 divided by K. Already we know this condition. The value of E2 dash we can calculate by E2 by K, right? So E2 by K is equal to what? E1. So this value, let us consider that this E1 value which is going to be equals to V1, and if the secondary full load voltage referred to the primary side, then V2 dash which is going to be equals to what? V2 divided by K. So prime regulation also we can calculate by using the formula for V1 minus V2 dash divided by V1 into 100 by making use of this simple formula. Now we will derive the condition for the voltage regulation. That is, what is the condition? What is the equation to calculate the percentage voltage regulation? I told you VR cos pi plus or minus Vx sin pi, this plus sign which represents for the lagging power factor, this minus sign which represents for leading power factor. So how this equation that we get, there is some with making use of the vector diagram we can derive this condition. Now let me show you what is the vector diagram for this deriving the value of percentage voltage regulation of the transformer, and thereby we will derive the condition. Okay. So what is the percentage voltage regulation? V2 naught minus V2 divided by V2 into 100. This is percentage voltage regulation up we have taken. Percentage voltage regulation is equal to not V2 minus V2 divided by V2 into 100. So it is nothing but total voltage drop divided by V2 into 100. Now the total voltage drop, it depends upon the nature of power factor, isn't it? So based on the type of power factor, the value of voltage drop which will be get depends. So the approximate formula to calculate the voltage drop that we can derive it as V2 naught is equal to V2 plus I2 R naught 2 plus I2 X naught 2. How we will get this equation? Let me show you with the circuit diagram. It will be more clear for you. See this circuit diagram. V2 naught is nothing but what? A no load voltage. So this is full load voltage. Full load voltage means across the load during the full load condition, whatever the voltage which we are having, that is V2. So no load condition, if I wanted to calculate, means here I will get the no load voltage. So this no load voltage across this, how it is going to get V2 plus the voltage drop across this. What is the voltage drop across this? I will get I2 R2, and what will be the voltage drop across this? We will get I2 X2. So the same equations I have represented here. You can go through. And let us derive how this equation V2 naught is equal to V2 plus I2 R naught 2 plus I2 X naught 2 that we will get. Okay. So if you see, if you just go looking into this vector diagram, it will be very clear. First, let me represent the V2 vector. V2 I am taking as a reference. I am considering it for the lagging power factors. So for lagging power factors, always the current which will be lag behind the voltage. So this is the voltage means this is the current I2. So current which lag behind the voltage by angle phi 2. Current is lagging behind the voltage pi 2. Okay. Now I2 R naught to drop, if I wanted to represent, means just draw a parallel line with this which is in phase with the I2. So in parallel to this I2, I have drawn a vector which is called as I2 R naught to drop due to the resistance in the secondary winding. Okay. And for this one, if you draw exactly with 90 degrees, if you draw a line, then this line which represents, or this vector which represents the drop due to the inductive reactance I2 X naught 2. Now if you draw one vector which is vector addition of these two, then the resultant of which one which we are going to get it as I2 into Z naught 2. Okay. So V2 plus I2 Z naught 2 or V2 plus I2 R naught 2 plus J I2 X02 is equal to what? Not V2 or V2 naught. This is nothing but the no load terminal voltage of the secondary winding. So this equation is now satisfied. V2 naught which is equal to what? V2 plus I2 R naught 2 plus I2 X naught 2 that we get. Isn't it? So till now in the concept which we discussed, if you have any doubt, you can unmute from your side and you can ask me. Anyone, if you're having any doubt, you can ask me. Hello? Ishrat? Ishrat? Latashri? ಲತಾಶ್ರೀ
ಸರ್
ಅರ್ಥ ಆಗಿದೆನಮ್ಮ ಕಾನ್ಸೆಪ್ಟ್ ಈಗ ಪಾಠ ಮಾಡಿದ್ದು?
ಸರ್
ಅರ್ಥ ಆಗಿದೆನಾ? ಸುಮ್ಮನೆ ಹಾ ಸರ್ ಅಂತ ಇದ್ದೀರಾ?
ಇಲ್ಲ ಸರ್, ಅರ್ಥ ಆಗಿದೆ.
ಅರ್ಥ ಆಗಿದೆನಾ?
ಸರ್
Okay, no doubt another.
No, sir.
Okay. Mohan. Mohan. Momina.
Yes, sir.
ಅರ್ಥ ಆಗಿದೆ ನಮ್ಮ ಕಾನ್ಸೆಪ್ಟ್?
Sir.
ಏನು ಡೌಟ್ ಇಲ್ಲ?
No, sir.
ಏನ್ ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ವಿ? What we have discussed actually?
Sir, actually we discussed about voltage regulation of a transformation.
So voltage regulation is equal to what? It is the difference in no load voltage to the full load voltage to the difference of no load voltage and full load voltage to the no load voltage or full load voltage, right?
Yes, sir.
Yes. Okay. Two types of regulation will be there: regulation down as well as regulation up.
Up.
It depends upon the that is in the given problem which one is mentioned, that we will take into the consideration. Okay. And
Sir,
the vector diagram ಅರ್ಥ ಆಗಿದೆನಾ? Yes.
sir, vector diagram ನಲ್ಲಿ ಸ್ವಲ್ಪ ಡೌಟ್ ಇದೆ ಸರ್.
ಸಿಂಪಲ್ ಅಮ್ಮ, ಏನಿಲ್ಲ. ಇಲ್ಲಿ ಸರ್ಕ್ಯೂಟ್ ನೋಡಿದ್ರೆ ನಿಮಗೆ ಗೊತ್ತಾಗುತ್ತೆ. See this is circuit diagram. ಇಲ್ಲ ಅಂದ್ರೆ ಈ ಸರ್ಕ್ಯೂಟ್ ನೋಡ್ರಿ. ಈಕ್ವಲೆಂಟ್ ಸರ್ಕ್ಯೂಟ್ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ಇಲ್ಲಿ ಪ್ರೈಮರಿ ಡ್ರಾ ಮಾಡಿದ್ವಲ್ಲ, ಇದೇ ತರ ಸೆಕೆಂಡರಿಯಲ್ಲಿ ಏನ್ ಬರುತ್ತೆ ನಮಗೆ? R02 and X02 ಬರ್ತದೆ ನಮಗೆ, ಹೌದಾ? ಎಸ್ ಆರ್ ನೋ?
Yes, sir.
So in case if there is no load, then whatever the voltage which we are having, it is V2 naught. If there is a load, then the terminal voltage which is called as V2. So the difference in no load to the full load voltage, it is due to the voltage drop in the respective resistance and as well as the reactance only, right? Yes. So that is what which I have which we written here in terms of equation. If you represent not V2 naught or V2 naught, which is equal to what? V2 plus I2 or not 2. It is a drop due to the resistance and the drop due to the reactance. The same equation in terms of vector diagram I have represented. First, I have taken the secondary terminal voltage as reference. V2 phase I have taken as a reference. Okay, this is this horizontal line till A, OA, which represents the secondary terminal voltage on full load. Okay, and this is the vector diagram I am representing for what? For lagging power factors I am drawing. So for lagging power factors, always the current which is going to be lag behind the voltage by phi. So with respect to OA, the vector OI2 or I2 vector which is having phi 2 degrees, which is lag behind the voltage V2. Okay, now V2 I have represented. Now I2 R02 and I2 X02, if you add to the V2 vector, then we will get V2 naught. So first I have to represent I2 R02. How to draw the I2 R02 vector? I2 R02 is nothing but I2 R2 antandrenu, it is a drop due to the resistance. It is nothing but the voltage only, right? So this voltage drop due to the resistance, if I add to the V2, then the resultant vector is nothing but V2 plus I2 R02 we will get. But how to represent this I2 R02 drop? So since this is the voltage drop due to the resistance, always in the resistance the voltage drop, it is in phase with the current I2 only. ಈಗ ನೋಡ್ರಿ I2 phase ಯಾವ ತರ ಇದೆ ನಮಗೆ? This is vector I2 ಅಲ್ವಾ? So in phase with I2 ಅಂದ್ರೆ whatever the phase angle which this I2 is having, with the same phase from V2 if you represent, then that one which is nothing but I2 R02. Okay, I2 R02, just draw a parallel with respect to I2. Now it is in phase only with respect to I2, right? Yes. Next, I2 X02. Always the voltage drop due to the reactance, it is having 90 degrees with respect to R02. Okay, or 90 degrees with respect to voltage. So, sorry, 90 degrees with respect to voltage drop across the resistance. So, from this voltage drop across the resistance, if you draw a vector with 90 degrees, then this vector which represents the voltage drop due to the inductive reactance I2 X02. So if you add I2 R02 and I2 X02, then we will get I2 Z02. This is the vector OA which represents V2 and this dotted line which represents I2 Z02. ಸೊ v2 plus i2 z02 ಈ ಎರಡು ವೆಕ್ಟರ್ಸ್ ಸೇರಿದ್ರೆ ನಮಗೆ ಬರೋದು v2 naught. So this is the vector which is called as v2 naught, nothing but called as the no load voltage. Hope it is clear now. Momina?
Yes, sir. Yes, sir.
Clear, right? Innu enadru
Yes.
doubt ide nama?
No, sir.
No, okay. Nirmala? Nirmala? Shahin Begum?
Yes, sir.
Is there any doubt?
No, sir.
No. Okay. Stalin?
Yes, sir.
Any doubt in the concept which we discussed, sir?
No, sir.
No. Okay. ಅರ್ಥ ಆಗಿದೆನಾ? ಸುಮ್ಮನೆ ನೋ ನೋ ಅಂತ ಹೇಳ್ತಿದ್ದೀರಾ?
ಅರ್ಥ ಆಗಿದೆ ಸರ್.
ಅರ್ಥ ಆಗಿದೆ ಅಲ್ವಾ? Okay,
Yes, sir.
fine. So shall I continue then? Yes. So this is the vector diagram. This is the vector diagram which we derived based on this formula. Now let us derive one more equation for the that is for this. Okay. What is OA, which is nothing but V2? So with OA, which represents the secondary terminal voltage V2. What is AF? Now see here, in this one, this is I2 R02, right? From this, if you draw a perpendicular line, then it just meet this horizontal line at a particular point, and that point I have represented it as AF. So what is this this length AF, which represents? This is the angle same phi 2 which I have. Why this is having that is with respect to V2 vector? What is the I2 R02 vector which is having the phase angle of I2? Oh, sorry, phi 2. Why it is having phi 2? This AB vector which I have drawn in parallel to this I2 only. So with respect to this horizontal axis, this whatever the phase angle this I2 vector which it is having, the same phase angle the AB vector is also going to be have. So that angle I have represented with phi 2. Okay. So this AF is equal to what we are going to be get then? If this is phi 2, the AF is equal to AB cos phi 2 we will have. That is equal to what? I2 R02 cos phi 2. Similarly, what is BE is equal to? That is equal to FB. So that is equal to BC sin phi 2, that is equal to I2 X0 to sin phi 2 we will get. ಒಂದು ನಿಮಿಷ ಇಲ್ಲಿ ಸ್ವಲ್ಪ ಕಟ್ ಆಗಿದೆ ನಮಗೆ. I2 X0 to sin phi 2 ಅಂತ ಬರುತ್ತೆ ನಮಗೆ. ಓಕೆ. ಸೊ ವಾಟ್ ಇಸ್ OD is equal to? This total OD is equal to ಈ B ಹೆಂಗ್ ಬಂದಿದೆ ಅನ್ನೋದು ಅರ್ಥ ಆಗಿದೆ ನಿಮಗೆ? See here, ಇಲ್ಲಿಂದ that is whatever the AB which we are having, ಇಲ್ಲಿ ಏನಿದೆಲ್ಲ ಇದು ಒಂದು ರೈಟ್ ಆಂಗಲ್ ಟ್ರಯಾಂಗಲ್ ಆಗುತ್ತೆ ನಮಗೆ. ದಟ್ ಇಸ್ ABC ಟ್ರಯಾಂಗಲ್ ಇಂದ ನೀವು ಇದನ್ನ ಎಕ್ಸ್ಟೆಂಡ್ ಮಾಡಿದ್ರೆ B ಪಾಯಿಂಟ್ ಇಂದ E ವರೆಗೆ ಎಕ್ಸ್ಟೆಂಡ್ ಮಾಡಿ ಇದನ್ನ ಹಿಂಗೆ ಡ್ರಾ ಮಾಡಿದ್ರೆ ನಮಗೆ 5 ಪಾಯಿಂಟ್ ಡಿ ಇದು ಪಾಯಿಂಟ್ E ಆಗುತ್ತೆ. ದಿಸ್ ವಿಲ್ ಬಿ ದ ರೈಟ್ ಆಂಗಲ್ ಟ್ರಯಾಂಗಲ್. ಸೊ ಫ್ರಮ್ ದಿಸ್ ರೈಟ್ ಆಂಗಲ್ ಟ್ರಯಾಂಗಲ್, this will be the phi 2 angle. This is the same phi 2 which we are going to be have. Okay. And if I calculate this BE, what is this BE is equal to? The same vector length which the FD which is it is having. See here, from F to D, whatever the length which I am having, the same length BE also I am going to be have. Right. So I wanted to calculate this FD length. That FD length indirectly I am calculating by BE. Okay. Simple amma. From this B, this is the hypotenuse, this is adjacent side, this is opposite side which I am going to be have with respect to do here, right or not? This is having the same phi angle of this phi 2. Okay. Now if I calculate what if I wanted to calculate means, sorry, BE if I wanted to calculate means it is the same length of FD. ಇಲ್ಲಿ ಕಾಣಿಸಿದಲ್ಲ F to D ಎಷ್ಟಿರುತ್ತೋ ನಮಗೆ the same length which the BE which is going to be have. So this BE which is equal to what? BC into sin pi 2. So similarly the value of FD also which is going to be equals to BC sin phi 2 only. So by this way we can calculate I2 X0 to sin pi 2. Okay, this is BC is equal to what? I2 X0 to, so therefore what is BC is equal to? B into C. So it is nothing but I2 X0 to sin pi I will get. Yes or no? This BC is equal to I2 x naught 2 I have. So instead of BC, I have substituted I2 x naught 2. Sin pi 2 as it is, I will have I2 x naught 2 sin pi 2 I will get. So similarly, what is AF is equal to I2 R naught 2 cos pi 2 I will get. Why I2 R naught 2 sin pi, cos pi 2 only means cos pi 2 same as it is we have. What is the vector length? AB is equal to, AB is the length which is equal to I2 R naught 2. So the total vector length OD which is going to be equals to OA plus AF plus FD. So what is the vector length? OA is equal to V2, AF is equal to I2 R naught 2 cos pi 2 plus FD is equal to I2 x naught 2 sin pi 2 we will have. So what is this total vector length OD which is represents, okay, this OD which is nothing but equals to V2 plus I2 R naught 2 cos pi 2 plus I2 x naught 2 sin pi 2. So therefore approximate voltage drop which is going to be, how much it is going to be? This OD which represents the total no load voltage. So this, from this no load voltage, if you V2 if you shift to the left hand side, V2 naught minus V2 we will get, that is equal to I2 R naught 2 cos pi 2 plus or minus I2 x naught 2 sin pi 2 we will get. Why this plus or minus I have represented? For lagging power factors here, if you going to get a plus symbol, that is a plus sign. For the negative power factors here we will get minus sign. Okay. So for leading power factors also, no need to draw the vector diagram, and here it is already there. Okay. So for negative power factors, V2 naught minus V2 which we are going to get minus sign here. I2 R naught 2 cos pi 2 minus I2 x naught 2 sin pi 2 we will have. Plus we are going to use for the lagging power factors, and minus sign which we are going to be used for the leading power factors. So percentage voltage regulation is equal to what? V2 naught minus V2 divided by V2 naught into 100. Regulation down it is. Okay. In case if it is the regulation up means V2 we will take. What is V2 naught minus V2 we will have? V2 naught minus V2 is equal to, this is the total formula that we have. So I2 R naught 2 cos pi 2 plus or minus I2 x naught 2 sin pi 2 we will have. If you take I2 common, I2 of R naught 2 into cos pi 2 plus or minus x naught 2 into sin pi 2 divided by V2 naught denominator term same as it is I am keeping. So percentage regulation which is going to be equals to I2 of this total term into 100. Why? Because I am calculating here the percentage regulation, this total value with the 100. So we will get 100. Okay. Not only for the lagging power factors, for also the leading power factors and the unity power factor also, the phasor diagrams which have been shown here. See, this is V2. Okay. So in the case of leading power factors, current I2 which is going to be leading, this is I2, where the phase angle which is going to be phi 2. So with respect, that is in parallel to this I2 R naught 2 drop will be there. I2 R naught 2, this is the vector which is in phase with the I2 current, I2 R naught 2 drop, I2 x naught 2, this is I2 z naught 2. The phasor addition of V2 plus I2 z naught 2 which gives you the V2 naught, that is no load voltage. Okay. This is for the leading power factors. And similarly for the unity power factors, how we will get, this is V2. Okay. And since in the case of unity power factors, voltage and current which is going to be in phase, we will have this represents the V2 means in phase with this one only we will have the current also. So how the I2 R02 drop which is going to be in phase with the current. So in the same direction of the vector V2 only we will get I2 R02 drop, and exactly to this 90 degrees if you represent I2 x naught we will get I2 R02 and I2 x naught vectorially if you add, then we will get I2 z naught drop, and this V2 plus I2 z naught vectorially if you add, then the resultant phase V2 naught which you will have, that V2 naught which represents the no load value of voltage. So this is the generalized formula for all the power factors. Okay. So in case if you have the leading power factors, we will use minus sign. In case if you have the lagging power factors, we will use the plus symbol. Okay. So again, whatever the formula which we have in the above, it is get simplified. The percentage value of voltage regulation, this formula I have simplified like this. I2 R naught 2 cos pi 2 divided by V2 naught, right? So this one I can simplify it as the percentage voltage regulation is equal to 100 into I2 R naught 2 divided by V2 naught into cos pi, isn't it? I2 R naught 2 cos pi divided by V2 naught plus or minus 100 into I2 x naught divided by V2 naught into sin pi. Now, whatever this total one which I have, I am just write it as a VR, where VR is equal to 100 into I2 R naught divided by V2. I2 R naught divided by V2 naught into 100. I am taking it as a VR, where VR which represents this total term. So percentage voltage regulation, therefore I can write it as VR cos pi plus or minus same this total term I2 x naught into 100 divided by V2 naught, which is given by Vx. So therefore percentage voltage regulation, simply I can represent it as VR cos pi plus or minus Vx sin pi, where VR is nothing but a percentage resistive drop. This total term I2 R naught into 100 divided by V2 naught, which is nothing but called as percentage voltage resistive drop. And similarly I2 x naught divided by V2 naught into 100, which is nothing but percentage reactive drop, it is, that is represented with Vx. So therefore percentage voltage regulation with respect to primary winding, how can we write? Percentage voltage regulation is equal to I1 into R01 cos pi 1 plus or minus x01 sin pi divided by V1. And with respect to secondary, if I wanted to represent, percentage regulation is equal to I2 into R02 cos pi plus x0 to sin pi divided by V2 naught we will get. Okay, this is how we can calculate the value of percentage voltage regulation either with respect to the primary winding and as well as the secondary winding. Any doubt till now? If you have any doubt, you can unmute and you can ask now. Is there any doubt? Shall we stop or shall we continue with the next topic?